Afternoon, I'm Alex Stilling. I'm Sales Director for D&W. I can't hand out any free heat pumps or heat recovery equipment, so apologies in advance for that. But yeah, we work closely with the guys at Synacor, primarily putting some of our kind of technologies into your estates as end users or your customers. So I thought I'd set the scene on why the drive is there for decarbonisation, why it's important, what factors there are, and then we'll move into some of the solutions and architecture that we've got available. So the first one is obviously climate change, rising temperatures. The UK in 2022 saw its hottest year on record. 2023 wasn't as good, but still sat kind of fourth warmest year ever recorded. And in 2022 we saw the first average temperatures above kind of 10 degrees C. Policy drivers, obviously England and Wales are going to be net zero by 2050. Scotland have got a more aggressive target at 2045, and that is obviously driving a lot of the activity and solutions that we're seeing today. Energy security, obviously big a couple of years ago. Russia's invasion of Ukraine saw kind of energy prices skyrocket. They're still relatively volatile, and actually kind of fixing energy and reducing our energy consumption is really important. And the last one is CSR, public concern. Stakeholders, internally, externally, putting more of an emphasis on protecting the environment and reducing our impact in our operations and what we do. So I thought this was kind of interesting given where we are. So there was a United Nations kind of study that really focused on the impact of rising temperatures and anything above kind of 2 degrees C, what would be the impact certainly for the UK. The areas kind of highlighted red by 2050, if temperatures go above 2 degrees, could be flooded, which wouldn't be good. But certainly for where we are today, this is the impact potentially of areas that could be below the tidal line for the River Thames by 2030 if we go above that 2 degree threshold. So yeah, not trying to scaremonger, but I thought it was a pertinent one for today. So energy, and in terms of how we consume that energy, and therefore kind of the sector that we operate in HVAC-R, why is it important that we focus on decarbonisation? A study done by the government back in 2022 across kind of 6 real key areas, and I don't know if it's too clear on the side, it looks like it is, but they focused on really factories, offices, large food shops, hospitals, higher education and leisure centres, and you'll see that the 3 main bars on there, so the red is heating, the kind of turquoisey blue is cooling, and the light blue is hot water. So in many cases, well over 50% of the energy consumed is in the sector that we focus on. So we can have a real big impact by moving technology on and looking to decarb. Another big factor is policy. Obviously, I won't go into too much detail on all the different policies that are driving us towards kind of net zero. Certainly, the UK net zero carbon building standards is an important one. And we've also got the F-gas regulations, certainly for refrigeration and heat pumps. And that is looking at reducing the amount of high GWP gases that can be placed on the market, sold on the market, but also banning outright some refrigerants that are really, really high. So the UK and the EU now have 2 differing regulations, and I'll touch on it in a little bit more detail a little bit later on. It's probably likely that the UK will adopt a very similar kind of standard to the EU, but we're slightly delayed on that being published. So I talked around kind of there's 2 strands. One, reducing the amount of refrigerant that can be sold on the market, but the outright ban. So 404A, which was a common refrigerant, everybody's probably heard of it, is now banned, and you can't put that in new systems moving forward. A replacement for 404 was 448A, and actually now we'd advise not to put new systems in on 448A, 449, 410, which is a very common refrigerant in air conditioning and heat pumps. And actually, we need to be transitioning on to lower GWP alternatives. So 410 R32 is a lower GWP version. 454B you're starting to see in some chiller applications and heat pumps as well. And then you've got YF, which is a refrigerant primarily used in car air conditioning, but does have applications in chillers. But by 2030, new systems on these gases might not be the right solution to future-proof your business, and that really leads us down the natural path. So CO2, hydrocarbons and ammonia being the only real guarantee for the life cycle of your equipment. Touched on kind of CSR and its kind of role in tackling kind of climate change and that decarbonisation piece. Most people in this room will probably be aware of the impact of your Scope 1 direct emissions, Scope 2 and Scope 3, and the reporting around ESG that needs to be done. Obviously, direct emissions are those generated by your kind of operations. Scope 2 is the energy that we buy, and Scope 3 kind of is everything else. So business activities, suppliers, which is where obviously we as a business are really, really kind of focused and targeted on. So what are we doing as a business? How are we supporting our customers like Synacor to support you? We class ourselves as more than just a wholesaler. We've got lots of different value-added strands of the business. One of the most important things is providing the right technologies, the right solutions for your estates, and actually supporting that, whether it's through design, through training, kind of post sales. So we've got a dedicated technical sales team. Alan, my colleague who specialises in the Mitsubishi Heavy Industries range, is one of those people who will take a concept and an idea and make it a reality for you guys in conjunction with Synacor. We help the contractors advise end users on what the options are. So we will present you guys with all the options that are available, and you guys can then make the choices as to what is right for you. We'll prepare the applications and the specific proposals alongside all of our partners, and we'll support the contractors from start to finish. We can then monitor and report on performance. It's a really, really important aspect of what we do, especially with some of these newer technologies. I'll touch on heat recovery a little bit later, but actually giving you guys the data on what we're saving, both from an energy point of view and a carbon point of view, is really important. And lastly, it's that account management and ongoing support, and that could be in terms of day-to-day support through the contractors, training. There's a whole manner of different things that we can layer on top. So decarb of hot water and heating generation. So what are the choices? What's available to us? Heat pumps you'll all be familiar with, so I won't go into too much detail on that side of things. But how does it help to decarbonise heating? Obviously, electricity and electrification, especially from renewable sources, really helps to reduce the carbon emissions in comparison to fossil fuels like gas. A heat pump is really just taking heat from the ambient, if it's an air source, from the ground, from water, and transferring that into a space, into an area. That is done in the normal kind of refrigeration cycle. So the refrigerant in the unit is compressed, that is then boosted, and the heat is transferred, normally via a plate heat exchanger, and that process just repeats and recycles through. The different types of heat pumps that are on offer, you've got air source, ground and water. So air is obviously extracting heat from the ambient. Even in cold temperatures we can do that, which is testament for the UK and ideal. Ground source is obviously used in boreholes to take the heat from under the ground. And water is really transferring that heat from rivers, lakes, and also sewage as well, which is a good use of heat. What are the advantages of using a heat pump? 4 key ones. I could have put loads more on this slide, but I couldn't fit it in. But efficiency, sustainability, I think versatility now, certainly some of the solutions we can provide can not only give you heating, can give you cooling and hot water as well. And then longevity. These things are built to last. So what solutions do we have and what can we provide, again, in partnership with Synacor? So we have our MHI range, and not to be confused with Mitzi Electric, they're completely different companies. But within MHI, we've got a monoblock air-to-water heat pump utilising R32 or CO2. So the Hydrolution is on R32, mainly used in kind of domestic and small commercial applications. And Q-Ton, which is a larger capacity unit, is then used in kind of commercial and light industrial. And we'll touch on Q-Ton in a lot more detail as we go through. Secondly, we've got what we call the smart heat pump. So this is built by a manufacturer in Italy called SCM Frigo. They're a leader in kind of CO2 technology. They build air-to-air or water-to-water heat pumps. And the capacity starts at about 30 kilowatts and goes up to about 300 kilowatts. So, yeah, really ideal for kind of retail, commercial and industrial applications. Lastly, our parent company Bayer own a Danish manufacturer of heat pumps called Fenergy. Fenergy are a relatively new player on the block. They started in 2020, but have already kind of sold and supplied a couple of hundred heat pumps, primarily in Scandinavia and Northern Europe. These heat pumps are all on natural refrigerant, so you've got hydrocarbon or CO2. They're air-to-air, air-to-water or water-to-water, but they also manufacture chillers as well. So their standard range is 600 kilowatts to 3 megawatts. Biggest one they've done is about 13 megawatts for a district heating project over in Denmark. But again, you're talking large commercial applications, industrial, and like I say, we're doing some district heating projects in the UK now, which is really cool. So, an introduction to Q-Ton. What is it? Q-Ton is an air-to-water heat pump. It's CO2 and it's a monoblock unit. So what I mean by a monoblock is all the refrigerant is contained in the outdoor unit outside. So all that you have running inside the building is your water. It's highly efficient, so we utilise a compressor manufactured by Mitsubishi themselves, a rotary compressor built in Japan, and each unit can produce 30 kilowatts of kind of heat output, and that can be modulated in a master and slave configuration up to 16 units, so just shy of 500 kilowatts worth of output. What are the benefits? Well, we can deliver kind of hot water temperatures from 60 to 90 degrees, and that's even down to outside temperatures as low as minus 25. You'll get 100% capacity out of the unit down to minus 7, and then you'll see a small drop off the lower we go in terms of temperature. In comparison to a gas or electric kind of boiler or heater, we see reductions in running costs of anywhere between 76 and 46, depending on the heat generation, and an efficiency saving of kind of 75%. So it's big numbers. I said it was on CO2, so the GWP is 1. No ozone depletion potential, so that's again a really good selling point for the environment. And they're built to last. You know, long-term reliability. It's high-quality products, like I say, manufactured in Japan, and it's easy to operate. So the control panels look like AC air conditioning controls. The logic is determined with you guys as end users to know what your peak loads are, where your demands are, and we can control and provide that hot water to suit. This is where somebody like Alan comes in partnership with Synacor in terms of really getting the most out of the unit, and depending on what the sector is, depending on what the application is, depending on how many people are using a hotel, a spa, a gym, will really determine kind of how many Q-Tons we need, what the regeneration of the hot water looks like. But you can see on average from a 30 kilowatt unit at 65 degrees C, we can produce kind of 500 litres per hour. At 90 degrees C, that drops down to about 300, but it still shows there's a lot of capacity there in the units to extract. So that's what Alan, the team at Synacor, would plan and map out with you guys, and we would design that solution to suit. So what have we done with Synacor? We've done lots of projects on Q-Ton with Synacor, which is great. The Easy Hotels being one that we've done, certainly a lot of projects in 2024, and this is just a snapshot of some of those projects. There's kind of various different configurations, so normally between 2 and 3 kind of Q-Tons, plus then a variety of different tanks depending on what replenishment rates they need, what space is available to us, so on and so forth. So yeah, you can see the guys at Synacor have done a fantastic job of installing all of that equipment. So that was kind of heating and hot water. Feel free to talk to Alan and I kind of after this, or fire any questions at us depending on what your applications are and how those solutions can suit. But in terms of refrigeration, what options are there and what can be done to again decarbonise that part of your estate? So I touched on regulations earlier. It's a massive driver in refrigeration regulations. It's really pushing the manufacturers to bring the latest technology to the market. I said the EU and the UK differ in terms of F-gas regulations and where they're at. The EU in 2023 brought forward kind of proposals around F-gases, and previously they were on a trajectory of phase down, so they were going to allow some HFC refrigerants, some higher global warming refrigerants to remain. That's gone. They're now on a phase out journey, so by 2050 there'll be no HFC refrigerants available in the EU. You won't be able to use them. Why is the EU regulation kind of important to us? Well, the Climate Change Committee have advised the UK to just do a carbon copy of the EU regs and align once again on that. So that will mean potentially that our regulations will change and we will become much more aggressive in terms of some of these phase downs and targets that we're going to put in place. The quota fee tax is a really interesting one. So the EU are going to put a levy on any refrigerant being sold as of the 1st of Jan next year. And that is based on the CO2 equivalent tonnes of that refrigerant. So 410A, I said, is a common refrigerant in kind of older heat pumps and air conditioning. That tax will equate to about £6.50 per kilo in the EU. The UK is probably not going to miss an opportunity to take more money off people. So I can see that one coming in, even if they don't move the regulations forward and move that on. The UK were expected to bring this revision in 2024. Like most things in the UK, it's slightly delayed. We don't know when that new regulation is going to come in place, but we think it's going to be at some point this year. And what you will start to see, probably moving into 2026, is refrigerant pricing going up, availability kind of certain gases, those high GWP ones, being harder to come by. So what can you do now? What solutions are available to you? So in terms of capital equipment, so whether that's your condensing unit, your pack, you can move that onto new technology. So that is CO2 or what we call ultra-low GWP refrigerants. So that is something like 454C, 455A being the two kind of most common ones that we're seeing in the market at the moment. You can optimise the performance of your existing equipment. So this is, again, where a contractor like Synacor really comes into their own. It's that proactive maintenance, the planned preventative maintenance, making sure that your systems are running in the most optimum way so that you're not consuming more energy than you need. Also, you can use monitoring equipment to really analyse what's going on in your systems, in your kind of properties, and then using that data to drive certain activity. The last one is improving the system efficiency. So that is upgrading componentry, whether it's a compressor, a fan speed controller, an inverter, to really try and make that system work better. But also then implementing new technologies, one of those being heat recovery. So what solutions can we provide as Dean & Wood? Again, talked about SCM earlier. They're a leader in CO2 refrigeration equipment. So they build condensing units, packs and chillers, and they, from a medium temperature range, start at 0.5 kilowatt, go to 1.5 megawatts. On an LT, again, you're in and around 0.5 kilowatt up to about 600 kilowatts. We also supply and distribute products from other manufacturers, so Bitzer being a well-known German compressor manufacturer, but they also make condensing units. And they've got A2L condensing units readily available to be sold in the UK. Danfoss is probably a name everybody's heard of. They're a global leader in cooling and heating products. They've also got a range of A2L condensing units, but also CO2 condensing units that we distribute. And they also do IoT modules to monitor and analyse system performance. So I touched on heat recovery kind of earlier on in terms of improving a system's kind of performance and giving you more from what you've already got. Heat recovery isn't new. Heat recovery's been around for many, many years. But our SEC panel, which stands for Sustainable Energy Controller, moves heat recovery onto a new level. And I'll come on to some of the kind of uniqueness of the system in a little bit. It's manufactured, again, by SEM, which is part of the Bayer Group in Italy. And it's a patented product with all of the kind of the intelligence of the system being in the PLC. It provides an end user with free heat, which is really, really important. The byproduct of cooling is heat, and that is normally kind of just rejected into the atmosphere, and we actually capture that heat and do something productive with it. We've got two versions of the box available, one which is compatible for A1s and A2Ls, and that's in the same box. So if you've got a condensing unit that is running on 448 today, and you switch over and decide to put 454C in, for argument's sake, which is a lower GWP refrigerant, the SEC panel doesn't need to change. It's compatible with both. Then we've got a version that is available for CO2, with the first units going into Yeovil Hospital at the moment. So yeah, a really kind of important milestone for us as a business. What are the benefits? So we can remove direct carbon emissions related to the generation of hot water. We can reduce the energy and the operational costs related to generating hot water. We can improve the efficiency, and this is probably a softer benefit of the SEC panel, but if you've got systems that struggle in high ambience, you know, certainly in London where you've got things located internally, actually by us removing the heat, that will help the overall kind of cooling performance of that system. It's a future-proof technology, and typical paybacks, which is a really important factor in all of this. We see for kind of electric generation of heat is probably 12 to 18 months. If you've got a gas boiler, then typically it's between 12 and 24 months. So really kind of quick payback on your investment. I said the technology is unique. Why is it unique? Typically, heat recovery will only occur if you've got a cooling demand. So in the summer, your refrigeration equipment, your AC equipment will be running flat out, and you'll get lots of heat as a byproduct. In the winter, that's completely opposite. Your fridge kit's hardly running, and therefore you're not going to get any heat. What SEC will do is almost force the system to run like a heat pump. So what we have in there are two-plate heat exchangers, and we've got two different modes of operation. Firstly, we do heat recovery, so that's when you've got a cooling demand, but you've also got a hot water demand, and we'll just bypass that refrigerant through the first plate heat exchanger, take that heat out and put it into your hot water. If you've got no cooling demand, but you've still got demand from the hot water side, we've got a second plate heat exchanger that really acts as a false load evaporator. That's when we'll engage that second plate. We'll take the heat out still, we'll keep the compressor running in the outdoor unit, and we just pulse liquid down into the indoor unit to get that residual heat out of the system. So we see COPs typically in harvesting or heat recovery mode of about 4, and in the heat pump mode we're still getting about 2 from a COP. So for every 1 bit of energy you're putting in, you're getting 2 out, or you're putting 1 in and you're getting 4 out. So a traditional system, as I say, you'll have the cooling side and an energy input, and then you'll have your boiler electric immersion with an energy input. SEC can remove that energy input in its entirety on the hot water side, or it can be the main source of hot water being delivered with a gas boiler or electric immersion just backing it up or topping it up. In heat pump mode, that's when obviously I've talked about the cooling side being satisfied, but there's still a need for the hot water, and the PLC really is understanding the inputs from the heating and the cooling side. Those bits of equipment don't even know that the panel's there, and it's really kind of manipulating and getting the most out of each element. So we've got two main configurations that we use. Primarily the installations that we've done of SEC are in what we call a preheat configuration. So that is your SEC panel is connected to your refrigeration side, your cooling side. We then deliver hot water, if it's the A1, A2L version, at around 50 degrees C into a tank. That tank then feeds the main hot water cylinder that has still got a gas boiler or electric immersion connected, and that will really lift that water from 50 to 65 for Legionella and other bits and pieces. The other way we can do it, and certainly this is going to be more commonplace with the CO2 version, is in a direct format. So SEC will deliver water, as I say, at 50 degrees C, and if you've got the A1, A2L version, you'll have a coil within your tank which will then do the rest of what is needed to get it above 65. For the CO2 version, you won't even need that. The only thing the coil will do is really store that hot water. The CO2 version, we can deliver water at a minimum of about 70 degrees C, but we can take that right up to 90 degrees C, so it gives us a lot more kind of flexibility on what we can do. So what are the potential applications and where have we done kind of the installs that we've done up to now? Cellar cooling, a prime example, really good in pubs that do food and beer as an offering. The first one that we put it in, which was just a wet lead pub, I was talking to a few people earlier, they didn't seem to use the facilities in the bar all too often to wash their hands, so the hot water demand was quite slow, and yeah, the return on investment was a little bit longer. So it's a pub in Leeds. I won't go into the details, but I wouldn't eat nuts from that pub, let's put it that way. Cold storage, so food manufacturing, food processing is a really good use. So you've got a constant cooling demand coupled with a constant hot water demand, whether that's for the manufacturing process, whether that's for wash down, so on and so forth. There's a high hot water usage. Bars and restaurants, again, we talked about that kind of food-led piece. Got food retail, so obviously you've got cooling demand off display cabinets, and then a need for hot water for welfare facilities, staff facilities. Fast food, prime for fast food, again obviously constant hot water demand and a constant cooling demand. And lastly, hotels, and I've talked a lot about refrigeration and the use of SEC on refrigeration. In this example of the hotel, actually that's on the air conditioning units that are doing the server room at the hotel, so it can be connected to air conditioning equipment as well. The most benefit you'll get is when that air conditioning is doing cooling only, but we can do it off cooling and heating as well. So just kind of two examples of where it's been installed. Netherend Farms, that's an artisan kind of butter production facility. So yeah, in this example, we sold the whole kind of refrigeration package, the outdoor, the indoor. SEC was bolted on as well. They're controlling a room at around kind of 10 degrees constantly throughout the year for that butter production. And again, there's a high hot water demand driven by their kind of cleaning processes, wash downs and things like that. So why are Dean&Wood and Synacor the right partners for you? So we touched on the scopes and how important kind of scope 1 and 2 and 3 are. I think between kind of the two of us and the partnerships that we've got, we're ticking all the boxes for all of those scopes in terms of new products that we've got available, reducing kind of electricity consumption by energy efficient technology. And then from a Dean&Wood point of view, we're really working hard with our supply chain to remove as much carbon out of our operations as possible, and we're committed to be net zero by 2040. Perfect, thanks very much.